Hey everyone, and welcome to The Explainer. Today, we're embarking on a truly mind-bending journey, the paradigm shift to quantum physics. We're going to travel from the safe, highly predictable reality of our everyday lives straight into a surreal, microscopic alien world where, well, absolutely none of the rules make sense anymore. So, strap in because get ready to have your entire understanding of the universe completely challenged.
Okay, let's dive into this. To set the stage, just listen to Niels Bohr, one of the founding fathers of modern physics. He said, "Anyone who is not shocked by the quantum theory must not have understood." Basically, if you aren't completely floored by what we're about to cover, you simply haven't grasped it yet. I'm warning you right now, the existential shock of quantum mechanics is very, very real. It just completely shatters human intuition.
You know, when we think about exploring bizarre alien worlds, our minds usually jump straight to sci-fi tropes, right? Like the Starship Enterprise voyaging across billions of light years of deep intergalactic space. But the truth is, the weirdest, most rule-breaking, surreal exploration in human history didn't happen in deep space at all. It happened down at the scale of billions of an inch. It happened literally right inside the microscopic atoms that make up our very own bodies. Now, if you're suddenly panicking about getting lost in advanced calculus today, take a deep breath. We are going to explore this massive paradigm shift without any dense math. Instead, we'll rely strictly on visual concepts, inspired by our source material, Quantum Physics for Poets, which is just a brilliantly accessible guide to these ideas. Our goal here is pure, focused understanding. To understand just how crazy the quantum world really is, we first have to understand the comforting illusion we lived in for hundreds of years. Starting with Galileo back in the 1600s, then moving to Isaac Newton, and finally to Maxwell in the 1800s, classical physics basically convinced us that we lived in a clockwork universe. Everything was orderly, everything had a clear cause and effect, and above all, everything was fundamentally predictable. Let's look at Newton's famous cannon thought experiment to see this predictability in action. Imagine you put a cannon on a cliff. If you use a little bit of bad gunpowder, the ball just fizzles and falls straight down. Use normal powder, it forms a beautiful mathematical parabola and lands miles away. But use enough superpowered powder and you put that ball into a perfect orbit around the Earth. The math works perfectly every single time. So the crucial point is this. In classical physics, if you know the exact initial conditions, like the exact amount of gunpowder, the angle of the cannon, the wind resistance, you can perfectly predict the future. There are zero surprises. It's a universe of absolute certainty and strict determinism. But then, an anomaly popped up, a massive crack in our classical intuition. Scientists began to ask a seemingly simple question: what exactly is light made of? Isaac Newton was absolutely convinced light was a stream of tiny, straight shooting particles, which he called corpuscles. But others, like Christian Huygens, strongly argued that light was a wave, much like ripples on a pond.
Before they could even figure out what it was made of, they had to figure out how it behaved. Thanks to some brilliant astronomical observations by scientists like Ole Romer, humanity finally pinned down the mind-boggling speed of light, exactly 186,000 miles per second. That's enough to circle the globe over 7 times in 1 second. This proved that light doesn't just instantly exist everywhere, it actually travels through space.
The true nature of light was finally exposed in 1807 by a polymath named Thomas Young. He fired a beam of light at a barrier with 2 narrow slits in it. Now, if Newton was right about particles, the light should have just gone straight through those slits and formed 2 bright lines on the wall behind it. But instead, the light spread out, bent, and interacted, forming this massive overlapping pattern of multiple bright and dark stripes. And this brilliantly illustrates the concept of wave interference. Think of it like water waves. When the crest of one light wave meets the crest of another, they add together to make an even brighter light. But bizarrely, when a crest meets a trough, they actually cancel each other out. That means you can take 2 beams of light, add them together, and literally create total darkness. Young proved light was a wave. Case closed. Or so they thought. Fast forward to the 1920s, and well, everything just fell apart. Scientists finally developed the tools to look really closely at the atomic world. They fully expected to see tiny clockwork gears and predictable little solar systems. Instead, they discovered the quantum shock. They found that particles, like electrons, don't follow clear, predictable paths at all. The absolute certainty of Newton was suddenly replaced by fuzzy statistical possibilities. As you can imagine, this triggered absolute existential dread among the greatest minds in science. Max Born introduced the idea that subatomic particles are actually governed by probability waves, meaning you can never exactly predict where a particle is, only the odds of it being there. Albert Einstein fiercely rebelled against this. He wrote to his colleagues, completely disgusted, stating he could not believe in a God that plays dice with the universe. To really understand why Einstein was so upset, let's make the absurdity of the quantum world tangible. Imagine playing a game of tennis against a solid concrete wall. You hit the ball exactly the same way every time, but instead of bouncing back, 45% of the time, the ball magically phases right through the solid concrete. In the microscopic quantum world, this happens all the time. It's called quantum tunneling. Solid objects just randomly ignoring physical barriers. No way, right? You can actually see this probabilistic behavior in everyday life. Think about looking at a storefront window. Our source material uses the example of a Victoria's Secret display. When light particles, or photons, hit the glass, you see the mannequins inside, but you also see a faint reflection of yourself. Quantum physics tells us that 96% of the photons pass through and 4% reflect back. But here is the absolutely maddening part. We can never ever predict what any individual single photon will do. It is pure chance. And hey, it wasn't just Einstein who hated this. Erwin Schrödinger, the brilliant physicist who literally wrote the foundational mathematical wave equation of quantum mechanics, was utterly horrified by the probabilistic monster he helped create. He was so upset by the loss of classical predictable reality that he openly regretted his own Nobel Prize-winning discovery. Now, what's really interesting about this slide is that things get even weirder. Werner Heisenberg and Niels Bohr realized something that sounds like pure magic. Reality at the subatomic level doesn't actually lock into a definite state until you look at it. Prior to measurement, a particle is just a fuzzy cloud of possibilities. The very act of conscious observation or measurement forces the system to collapse and finally choose one specific reality. Einstein thought this was completely ridiculous, so he devised the ultimate challenge, known as the EPR paradox. Imagine two entangled subatomic particles created at the same exact time. Let's call them Molly and June. They shoot off in opposite directions across the cosmos. Molly zooms light years away to the star Alpha Centauri, while June stays here on Earth and heads to Peoria, Illinois. Because they're entangled, their states are linked as a mix of overlapping possibilities. But according to quantum mechanics, the second a scientist in Peoria measures June, she locks into a definite state. And instantaneously, faster than the speed of light, Molly, way out at Alpha Centauri, is forced to lock into her corresponding state too. Einstein mockingly called this spooky action at a distance, believing it proved quantum theory was broken because nothing can break the cosmic speed limit of light. But actually, scratch that, decades later, experiments proved Einstein wrong. This spooky action is 100% real. To highlight just how absurd this measurement problem really is, Schrödinger came up with a famously malicious thought experiment to drag the fuzzy probability of the atomic world right into our everyday macro reality. You take a sealed box, inside you place one living cat, a flask of lethal gas, and a radioactive atom with an exact 50% chance of decaying over the next hour. If it decays, a Geiger counter triggers a hammer, breaks the flask, and the cat dies. So here is the ultimate paradox I want you to confront. The box is completely sealed. You cannot see inside. Exactly 1 hour passes. You know there was a 50-50 chance of decay. So right at this moment, before you look, is the cat dead or is the cat alive? Let's move to and see how this builds. According to the strict rules of quantum mechanics, because the atom's state hasn't been observed yet, it exists in a superposition. It has both decayed and not decayed simultaneously. Therefore, the trigger has both fired and not fired. Which means mathematically and physically, until you open that box and force reality to collapse by measuring it, the cat exists in a mixed, overlapping state of being completely dead and entirely alive at the exact same time. Which leaves us with a deeply unsettling reality to ponder. We just learned that the microscopic foundations of our universe are governed by fuzzy chance, spooky connections, and overlapping realities that only solidify when observed. But you, me, the screen you're looking at right now, we are all just massive collections of those exact same atoms. So, I'll leave you with this. Since our entire world is built out of this quantum weirdness, are we, ultimately, all just cats in a box waiting to be measured? Thank you so much for joining me on this explainer, and keep questioning reality.